Hi. It's been a while since I made a recording, put something together to show you what's going on. So I thought I'd give you a little bit of an update. After the last video, I spent an afternoon getting this base up on the stand and then getting the column up on the base. Now, each of these bases is well over 200 pounds, so it wasn't easy for a little old man to do, but I have an engine hoist, and I was able to use that to get it placed on the stand. You can see up here the plate that I recently made, along with the servo and its adjustable holder, all that fit together nicely and aligned with the ball screw connected to this saddle. The next thing I did was to do some fitting of this saddle onto the base, and in doing that I found that this jib, I've called this a gib for many years, and I guess a year or so ago I found out that I was mispronouncing it all those years, although there's lots of places on the internet where you can find this called a jib. But anyway, the correct pronunciation is jib. Anyway, when I bought all these castings, the fellow selling it to me, Aaron, who was the originator of Industrial Hobbies machine, he told me that one of the jibs was the wrong size, and I kind of thought that he told me that it was for the Z-axis. But when I started putting this together, that jib went in there fine. So in fitting this saddle to the base, I discovered that this baby was too fat. So the first thing I wanted to determine was whether or not the taper on this was the same as the taper between the saddle and the waist. And I did some various methods of measuring. It's not an easy thing to measure, but I pretty much assured myself that this taper is the same as the taper in there. Now the reason they're tapered, of course, is I guess on machine tools there are basically two ways of having an adjustable jib. One is that you have screws going in the side to press on this and use that as an adjustment. But the more sophisticated way, the way it is on this and the way it is on my big machine, is that this is tapered, the hole that it goes into is also tapered, and there's an adjustment screw that presses on this little shoulder and pushes it in so that you can adjust the play out of the saddle. Get it nice and snug, but still moving smoothly. So, okay, I had a jib with a correct taper on it, but it was too fat, and I measured it to be about 40 thousandths too fat. So, how to get it thinner? Well, I don't know how hard this is, probably not very hard, but it didn't seem to me that it was going to be a very easy job to thin it out on the milling machine. And I do have right over here a TNC tool and cutter grinder, and it will kind of, and does kind of, in certain circumstances, operate as a surface grinder. So the thing to do would be to set this up in my tool and cutter grinder and use it as a surface grinder and grind 40 thousandths off the one side. And I'll show you some pictures of that setup. Here's my tool and cutter grinder, universal. It's in pretty nice shape. I bought it and then reconditioned it, kind of. And I have a magnetic chuck for it, which enables me to do some surface grinding. There's the chuck. It's an old one. It operates on electricity. Here's the controller for it. The whole thing, I imagine, is very, very old, but it works good. So I set up an indicator here. I didn't take movies of doing all this, but what I had to do was traverse back and forth and then shim one side of the magnetic base until I got a consistent reading, a reading of 0. I tried using gauge blocks, but that wasn't working out very well. So I decided to make some screw jacks on the end of the magnetic base. I drilled and tapped, and this is the way I ended up making the adjustment for the taper. It was then just a matter of doing the grinding off 40 thousandths, and here's a picture of you. You can see how the adjusting screw rides on a lip of the jib. Here's another picture of it installed into the saddle on a Duesey. Here's another view of it. After getting the jib ground and fitted, I decided the next thing I was going to do was to start working on the nut carrier for the y-axis. This piece clamps up to the bottom of the saddle, which moves along the y-axis, and it clamps there by just one bolt and this boss, so this has to be a fairly good fit. And using the CNC milling machine, it was not a lot of trouble to make that. That's exactly centered between these two sides and a specific distance here, and the diameter fits a relief hole in the bottom of the saddle. I got to the point where I made all these holes and got 5 of them tapped, and of course broke the tap on one of them. Fortunately, the piece that bolts on there only requires 5 screws. It only has 5 holes. So that was not a big problem, although I didn't like making a mistake. Anyway, you can see that the finish on this, on some sides anyway, is not real great. And also, when I had this clamped in the vise on a milling machine, in order to make this hole, the first thing I did was to drill down through it with a 3/8 drill, and that went fine. But then I decided I was going to open it up with a 2-flute milling cutter, properly called a mill. Anyway, as I started to do this, the whole saddle of my milling machine started to shake. Now you can see that this is not a small machine. When I bought it, they told me it weighed about 4,000 pounds, 2 tons. It's a knee mill, has a 4 3/8 inch spindle, so it's quite substantial. It was obvious that what was happening was that the jibs needed to be adjusted. They were very loose. Now the machine has 4 jibs that I know of. Here we're looking at the one for the y-axis, and on the back of each one is a similar screw, which is a lock screw. So you loosen up the lock screw, in this case on the back of the y-axis, loosen it up, and then tighten this. And what I did was to keep tightening it, and with the servos disengaged, turn the pulley until I felt some resistance, and then tighten up with a lock screw. Here we're looking at the uh, one of the jibs for the knee. That knee is quite big, quite heavy, probably 1,000 to 1,500 pounds. And at the bottom there is also a lock screw, which you can't see here, but it's at the bottom of this column. And for an old man with shaky knees, that was tough to get to. I had to do one and then kind of rest and did the one on the other side of the column. And here I'm going to pull the camera back so you can see that this is the table that lies along the z-axis, or I'm sorry, the x-axis. And underneath here, you can see where the other adjustment screw is, way up under there. Hope you can see that. And on the other end, again, another lock screw. So with those all adjusted, I felt it was time to make a test cut or two. So here I'm turning the very same bit that gave me all the vibration before. It's approximately 3/4 of an inch in diameter, 2 flutes, high-speed steel. I'm turning at 200 RPM and moving at 2 inches per minute. Okay, with the piece remounted, the vise tightened extremely. I'm coming down the same slot, and you'll hear a change in noise when I start to cut new metal. Okay, there you can hear the change. You can see the chips coming off. And there's the end of the cut. So I did get some vibration. It wasn't bad. Probably what you would expect. That was a rather large cut. Cut was 3/8 of an inch deep. Here I'm making a cut. I'm only using maybe 20 to 25% of the width of the cutter, and here it is doing the same thing with applying a little bit of lubricant and air, and I'm pretty happy with the way this is cutting after having adjusted the jibs. Here at the end of the scene, I was using 2 cameras, and here you can see the 1 camera I was using. I also decided at this time that it was finally time to start using Mach 4. Here we're looking at a screen of Mach 4. one of the mill screens. There aren't a whole lot of screens available, but there will be. This happens to have a 6-axis. That really doesn't matter for what I want to show you. A couple of things that I really like about Mach 4 that convinced me to start using it. I bought it when it was first available. I think I got a little bit of a discount and some promises, and that seemed quite a long time ago, but now I think Mach 4 is at the stage where it's a very usable product. First, I want to draw your attention to this area over here on the left. This window is where the G code would appear if you loaded one. But it is also the window where you can enter MDI. So let's put in here, for instance, G0, X1, and then instead of pressing return, we go down here. First I have to enable and press cycle start. And you can see that we're quickly going to X1. Now, if I had placed that instruction there and hit return, I would go to another line. And there I could do an additional code, G1, feed 7, X, whatever, 0, let's say, make it go back down. And then maybe I want Y to go to 3, and then I want, I don't know, X to go to 2, and Y to go to 0. And by clicking on cycle start now, these things will all happen sequentially. Stop it. They would all execute. And also in this window, you can use any of the normally used Windows manipulation. For instance, if I highlight this, I could cut it, I could copy it, I could paste, I could delete it, I could select all, and then perhaps copy it and paste it into an editor, whatever that might be. And by the way, a nice new editor comes with Mach 4. That's the first thing I like about the new program. Another thing is over here, jogging. We have all the things we've had before in jogging. Here, in order to use the keyboard, you have to enable the keyboard. And that means that if you have keys that might do things other than what you're expecting, you might not want to have the keyboard enabled, like the arrow keys, for instance. So anyway, in the configuration here, we have to disable this. In the configuration, if you look at Mach, or rather plugins, keyboard inputs, you can see that Mach 4 comes initially with all of the jogging already set up. That is, you can do regular jogging and by pressing the buttons, the arrow keys, left, right, up, down, and you can move the Z-axis with page up and page down. But in addition to that, by holding down the shift key and using those same buttons, we can do rapid, and that's just no different than it was in Mach 3. But what I did not have before that we have now, and maybe it was possible to set it up before, but I didn't know how to do it. You can now press the control key and any one of those, And instead of getting a continuous movement or a continuous fast movement, you now get the incremental movement. And that all happens without having to mess around down here, changing from continuous to incremental and back again. Uh, anyway, I found that very useful, even more so in the lathe program than here in the mill program. Now, again, I'm sure Mach 4 has tons and tons of nice features, which I'm not going to talk about. But one that I am going to talk about is the new probing. My Mach 3 setup, I had created pages that did all of these same probes, but this really has it laid out nicely. Sometimes it's not the technology, but rather the presentation that gets you. So here we can do a single position, either X, Y, or Z probes, and these numbers are how much you expect the probe to have to move, and in the case of, and in the direction also. You have probes for corners, and here you lay out the information again. To surface centering, again, nothing new, but it's really laid out nicely, I think. Bores and bosses. I had this, but I never had the ability to do that. And then angle of a surface, I also had that. Now, the thing that really attracted me was that these probes will do a fast and then a slow probe. For instance, over here, if this piece were, I don't know, let's say 12 inches long, and I normally probe at 2 inches per minute, it would take a very long time to do this probe. So what Mach 4 has is a two-speed approach. This thing will do this probe at a very high speed, 20, 30, 40, 50 inches per minute, and then it will back off from the surface, whatever amount you set, and will make another probe at a much slower speed and for great accuracy. And then it'll pick up, it'll tear over the other side and do the same thing. It'll do that real quick, back off a tiny little bout, and then probe very slowly for accuracy. Now those settings are here under the settings. First of all, let me talk about this number right in here where it says 31. That's the normal G code for probing. However, with Mach 4, you can have 31.1, 0.2, 0.3, and what those indicate are different probes that you might have. You might have probes of various diameters or various lengths for probing in particular places. And so you can set up for all that in advance. Okay, so here is the slow feed rate. You might only want to go 1 inch per minute. And the fast, you might want to make that whatever, 40 inches per minute. And then this is the amount, after making the initial touch at this high speed, it will back off, and then it will make another approach at this low speed for a more exact measurement or finding. They also want you to set an overshoot amount. I'm not sure why, but I guess just to make sure that you're there, make sure you've got good contact. And also, I'm not sure about what this in position tolerance is. But anyway, and in addition to these settings, we have a way to calibrate your probing setup. So you can, let's suppose that you have a hole of that you have made to an absolutely accurate size, as good as you and your machine will make it. And you can then make probes and determine the diameter of the end of your probe, and also that will take into consideration the accuracy of the movements of your machine. So this will calibrate your whole setup. So I really like that about Mach 4, and it was one of the things that pushed me into changing over. Another thing about this probing is that you can use it to set the fixture. If if you're going to probe a corner here and you want right here this to be whatever x0, y0, which is quite often the case, you would be setting the fixture there. But you can also use Mach 4 probing to measure. And here, for instance, if you wanted to know the inside length of this thing or the outside size of this in either the X or Y direction, you could measure it. And if you had done your calibration accurately, this would measure the size of this piece just as accurately as your calibration had been. So that's nice also. Now this is one of the new Mach 4 lathe screens, and I'm also using Mach 4 now for the lathe. It also has the same abilities over here in the G-code window and the MDI. You can switch this window from one to the other. And it's here that I really like the jogging setup, because let's suppose that I'm going to do a very simple one-off. I've got a piece in the lathe chuck and I want to face it off quickly. I get close to whatever face is already there, and by using the keyboard, by using the control key and the arrows, I can move over whatever the increment is that I have set in here. So and then by releasing the key, I can then press the up button, which moves the machine along the x-axis, and make a cut. I can back out, again use the control to move over a specific amount, release the control, make another cut, and I'm finished probably. I've got a nice clean face to start with, doing whatever other machining it is I want to do. But it doesn't quite stop there. Mach 3 had a reputation for not being able to do very accurate threading. I never had much problem with it. I really had no need to make very, very exact threads, and I had no reason to make long threads. And also, my machine is set up so that it runs at a very constant RPM. But now with the advent of Mach 4 and some motion devices, for which the plugins have already been completed, can do very, very accurate threading, even if your machine varies in RPM while you're doing it. So that's another biggie. Now, also added to Mach 4 here is the wizards in Mach 3 have been replaced in the lathe portion of the program by this turn cycles. And I really like the way they're laid out and some of the things that they can do. Let's just look at turning here. Okay, So over here on the left, you set initial position. Suppose X is the diameter of what you're going to start working on, and you want to start at the face, which we'll call Z, 0. And then let's suppose we're going to turn this down to a 1/2 inch, and we're going to do it for a distance of a 1/2 inch. And we want the tool clearance to be 100 thousandths, and we could make the Z a totally different number, which there was no way to do in the former wizards in Mach 3. Down here, you can set your RPM, your feed rate, your depth of cut, and this thing that says pocket, that means which tool are you going to use, and also you probably are going to use the offset for that tool so that it would be the same. So it's you know, if you're going to use tool 2, you'd want to offset 2. And then this is for a roughing pass, and this is for a finishing pass. Your numbers might be the same, or you might want them differently. You might want to make, you know, the finish X depth maybe, I don't know, only 2/1000ths of an inch. And the same for the Z. So then there are some additional things. You notice that these corners are labeled E3, E2, E1. Well, here we have E1, and you notice how this changes. This is now a chamfer, and if I hit it again, it changes to a radius. And that would be E1, this corner here. And so you can do the same thing for here and here, E2 and E3. And where you set that up is here in the advanced part over here. So the radius of E1 could be whatever you put in here. You want to make it a 1/16 of an inch, put 62 thousandths in there. And if you wanted a radius in here at E2, you could set that here and then turn that on, and also if you want one here. Now also in this advanced setting, that you can set whether you want it feet per revolution or feet per minute, whether you want constant surface speed or just constant speed, whether you want clockwise or counterclockwise, flood or mist. I think that's all pretty cool. And then this up here says OD. If we punch on that, now we're boring instead of turning the outside. And we've got all the same options. We can do various things at the various corners, which is, I think, very, very nice. So, and you can also change the direction. I want to bore from the other side. I don't exactly know how you do that, but perhaps if you have a power spindle on your tailstock, you could do it that way. But certainly you can do this. You can do OD turning from left to right. So those are some of the possibilities here. And after you got it all doped out, you can add it to the job. What? I did something wrong here. There, it likes that better. So all of these work kind of the same way. You set the parameters, same types of parameters, and at the corners you get the same options to do it whatever way you want to do it. Let's suppose you cut once and then you didn't quite get there. You want to modify it a little bit. You can double click here and you come up with the same screen that you had. And so maybe this final position, you want to modify that just a little bit. You want to cut it a little deeper. A bunch of ways you could do that. You could, change the tool wear or the active offset down here in the lower right corner. This is an interesting cycle, the grooving one, because here you can actually cut a groove in a say in a V-belt pulley. You can also I don't know what that's for, probably for an O-ring of some sort. But here you can also do a straight cut, which would also work for, I mean, if you could go all the way and make it, use it as a cutoff. When I first saw this, it wasn't apparent to me. I'm thinking, to do these, you've got to know the width of the tool, and it wasn't apparent to me that it's sitting down here. Since this is a tool number and this is a tool offset, this is the width of the tool, and so then the program is able to dope that out. Taper, same thing, and it gives you you know, there's several parameters for doing a taper, and this lets you change which ones you're going to supply. I guess there are 4 possibilities in making that taper. For instance, well, I'm not going to go through them now. But anyway, by clicking this, you'll see that the blocks that are highlighted change. So you have to just enter the information where the block is bright. And we also have nice threading program. All the types of threading that you could think of, I believe. So the turn cycles, I really like them. After you get whatever series, you know, you could put a series of operations here, and you could also create a movement, say, for a tool change, set that up in here, and put that in between your operations. Down here, if you have a custom G code that you use often, maybe it's the machine setup or whatever, you can type it in here, and then you can recall it and quickly plug it in over here. It's nice. I really like it, and I'm enjoying using it the little bit that I have.